can easily.
I could go to the other one. I was going to do it the other way, just so they're not adjunct with Alex.
Whatever you want to do.
Okay.
Do you want to start with the second one? Or?
Yeah, the Ztour. Okay. I'll whip through that real quick.
Okay. So, with our last scheduled talks of the session, Don Brady will be talking about Ztour, and if he has time, then metadata allocation classes. Following that, we will have optionally a special bonus session, which will be determined by your interest, which I'll announce after Don is done.
Thanks, Matt. So now I'm standing between the beer bash and the bonus session, so no pressure, right? Yeah, so this one I'm going to go really fast. How many people are coming to the hackathon? Okay, so I'll go real fast here. I'll have this, it's better with the demo mode on this, because you can actually see it working, as opposed to, static slides. So I'll rush through this and get to the other one, and then tomorrow, maybe in the corner I'll set up and people can come by, as needed to see a live demo or maybe to, comment, ask questions. So move forward. So how many people have used ZDB? It looks like most people. Good. And there's been some really good putbacks to ZDB, so that indicates it's being used because people fix their pain points. So I'm sort of excited. And I didn't start using ZDB until probably a year into my ZFS experience. I was just afraid of it. It looked dangerous. But it turns out it's actually not so bad because it's a read-only user-land instance of your pool. So you can actually go in there and query. It's an incredibly useful tool once you get over your fear. And so this picture on the left is just a dump of, let's see, DD, the MOS layer. Basically, the D nodes in the MOS, that fit on the screen. There's 30 some odd there. So that's the dash D mode with actually two Ds. And with ZDB, you can actually get more and more information to the extent where it's more than you could possibly consume, even possibly a parser could consume. And so, megabytes of data. So that's sort of the caveat. It's like you can get what you want up to a point, and then you get too much information. For example, looking at all the blocks in the pool might not be a human endeavor, unless you're like Data from Star Trek, and you can just pull it in. But so that's sort of one of the downsides. The other downside is it sort of assumes you know where you're going, because you have to put in the right commands, the right number of Ds, or verbosity to get you what you want. So you have to know. It's sort of a flow control, but you have to know how to flow it. So it's hard to use. The other downside is that it gives you the ability to dump a block. There's the -R mode from the previous slide. But that's just raw binary data. So if you want to actually make sense of that, you got to go fire up MDB, which is another domain expert space. And so then you got to learn how to use that and dump the block. And then you got to remember where you were and go back to ZDB and get the next block. So it's sort of a harder, if you will, harder mechanism to drive. And so I had this crazy notion, being a file system guy, that what if you use the file system to browse? And so Fuse, I'll slice it up. Fuse is like this ability to make user-land file systems. You can, you just basically have to supply the needs. Like reader, it just says, hey, what's in this directory? And so without all the burden of learning kernel programming and all the panics, all that, you can do really simple file systems really quick. It's actually very powerful. And I think the first Linux port was actually based on Fuse because it was so simple. And unlike MDB, it's cross-platform supported. So I had this crazy notion. This was really was intended for the hackathon, but I'm kind of glad I went ahead and did it because it actually took longer than you could do in a hackathon window. So I took Fuse and hooked it up to the ZDB backend so that you can actually be sort of in control. You can use the file system to browse the metadata instead of having to type commands back and forth or getting too much data. So, and this is where a demo would be nice, but this is the equivalent of that first slide, but through the file system, basically. So I'm listing in the dnode array 32 per dnode block. There's 16K block. We can pack 32 in there. So this is just like listing that. You can traverse down. I don't know. I think on the next slide. Yeah, this is from the GUI, which is where it's actually more compelling, because you can actually, if you have a file system browser that lets you do little triangle drop downs, you can actually get the information you want by looking around. Anyway, so I'd love to have help on this. It's sort of a hack, but I think it has some benefit for newbies or people that want to sort of look at the pool without having to browse through megabytes of data. And there's some other things I've started prototyping, like some of the ZAP entries are actually object IDs, so that could be actually a symlink back to the place. So it actually would, you can enhance, as we go forward, we can enhance it. Same thing with extended attributes. You could embed related data, checksums or something in there. So anyway, that's, did I make that in 5 minutes? Yeah, okay. So that was my 5-minute, 50-minute talk on Ztour. And if you're interested at all, just catch me tomorrow. I'll be there. And I can give you a live demo or sign you up to help me finish it out. And the other benefit is Fuse is cross-platform. So this could work on any platform. So on the Mac, you can use the Finder. I don't know if there is a GUI browser on Solaris anymore, but anyway. So that was that. So now I have to go back, Matt. Okay. Now this is an interesting talk in that it sort of duplicates some of the stuff Alex talked about, but it it kind of drives home the point. We're a community, and we're going to overlap, and so it's to our benefit to sort of collaborate, and instead of everybody solving their own pain point, we can start maybe sharing some of the load. Real quick, metadata in this context, it's everything that's not like your file block, your level 0 file block, and in some cases, I think it could probably be considered an extended attribute file. When I first brought this up, I was only doing metadata operations, and then I kept seeing traffic into the main pool, and it turned out it was SEL Linux was putting security attributes, and so those show up as files. And so that was like, oh, okay, that we might want to treat that as metadata. So the motivation for us at Intel is we're moving to 16 meg blocks. That's I said 16 megs. I didn't say 16K. 16 meg blocks, and so that is for us sort of a new uncharted territory, because the metadata is 4K, and now we have 16 megs next to it. So the poor allocator is trying to accommodate these two guys that are very different. So and then even their access patterns are different. Metadata is always IOPS constrained, whereas with your regular file data, you want it to be more throughput based. So, and then of course, I mean, it's obvious everybody's doing it to some degree. It's sort of standard practice for any cluster distributed file system that you separate out the metadata, and then you have object servers for your file data. And it was real popular when, now everybody's going to Flash, but when it was like these, you could have a hybrid array where you could dedicate some Flash, but not have to have an entire array full of Flash. So as I mentioned, I think we're at a tipping point. At least we certainly are. So we have these two different needs, and they've been traditionally put into the same set region on the disk. And so what I'm hoping is, I guess I'm preaching to the choir, but just hoping that people get the point that, yeah, maybe putting them all in the same Metaslab container is not the best way to do it. So the proposed solution is real similar to what others have done. It's basically you want to decouple the metadata and the allocation paths that you're taking. Metadata, obviously a mirror is probably the best media for that, and then bulk data, you can, where you're not so constrained with IOPS, you can go with the RAID-Z. And then part of this whole isolation is as we look at it, we look at the allocation policies, and it's just crying for somebody to have a change. Instead of having one allocator, we had the dynamic fit, I think, which was a combination of best fit and first fit, and then now we have the new dynamic fit, which is trying to accommodate, different sizings, and then we can have the new, it's like we can keep doing that, or we can actually have classes where they each get their own appropriate allocator. A good example here is the slog. When that was introduced, I mean, it just made sense. It's like you don't want to be using your pool for transient data, so putting it into a separate metadata tier made sense. But even beyond that, like I was mentioning the policies, for transient data that has a lifetime of 5 seconds, a roving first fit across the media is way more appropriate than a best fit trying to find the perfect place. That's just a waste of time. So in that context, it made sense to have not only different media, but also different policies. And then how much you write, if you have a mirror or a set of mirrors for your slog, it's like how much time you spent filling one versus moving on will be vastly different from the guy you're streaming to. So I don't know, I'll go ahead. This is just sort of an overview of how ZFS works. And this has all been, it's in Kurt's book. It's well understood, but I think there's a site addition now. We're going to select a class instead of, at the DVA alloc phase, instead of just picking the basic pool, we have the opportunity to pick a class. And then from there is where all the policies take place. So you want to, if you have different classes, it enables you to have appropriate classes, basically, or appropriate policies. So like after you select the class, I mean, that could be based on whether your metadata or your size or something to that. Then you want to go to the next phase is selecting the group. So within a class, we have typically VDIVs, but they're groups of metaslabs, and that policy is largely depending on how you're load balancing. There's a bit of space biasing that maybe needs to take place across your different VDIVs. And then of course, if one of your groups is degraded, you kind of want to avoid that. Then when you get to the actual metaslab, that's where there's another policy tier where you have to sort of decide which of the metaslabs you're going to use. We have free fragmentation, and there's other biases, like for a hard drive, you might want to bias lower tracks. So then again, there's more policies there. And then finally, when you select the block, that's where you definitely want to have different policies depending on what you're serving up. So trying to select a block when your block can be 4K or 16 megs is a little bit harder for any type of a generic allocator. So basically, the idea behind what I'm envisioning here is the allocation class is a way to sort of leverage existing mechanisms, like we do with the slog, but taking it to the next step, so that we can leverage the fact that there's policies in there, and so each class can have distinct policies instead of trying to have a global one-size-fits-all policy. We can have policies appropriate to a class. For example, the slog one, like I mentioned, it's going to have different characteristics. And this is sort of a refresh from what Alex talked about. There is, to date, a normal and a log class, and they called it a special class. It's basically the ability to have other classes in there. And it'd be nice to have sort of a common approach to that. I think in our implementation, we used an array because we envisioned having a whole bunch of them, so it's not necessarily static. And then I think the question was raised earlier is what happens when that tier is full. We're envisioning it as a wholly provisioned tier that you did the right thing, you measured it, and so it's adequate. But just like you have gang blocks, sort of this worst case, what if we do really run out of space? Like in the case of a gang block, it's sort of a fallback mechanism. So it will always fall back to the normal class, which can take any allocation. So let's see. So yeah, some of the sort of the caveats of an approach like this is that it presumes that you have space in your array or in your budget to put all your metadata in a separate tier. And that, in some cases, that makes sense because metadata is, 5% in the worst case, but typically a lot smaller because of compression. But if you can't, if for real estate reasons or, like I mentioned, economics, like to put in an SSD tier and you want to support HA, then you got to go to SAS. So it can be a cost barrier as well. So this is sort of a recap, and it looks eerily similar to what Alex was talking about. You have this stage in the pipeline where you do an allocation, and we have a chance now to pick the class. It's sort of a new step in that selection process. And so if you get your metadata, you can go down into your own dedicated class, your own dedicated group, and your own dedicated set of devices. And everything else goes in the pool. And the scale is, like I said, 5%. So, but the dilemma with this, like I mentioned, the caveats was like, what if you can't do that? Is it possible to separate your metadata and your file data in the same pool, one pool, in a way that makes sense? And so we've been experimenting with that, and it's not as scary and it's not as strange as you would think. Although, talking to Matt earlier, there is this assumption that we have that metaslabs are autonomous and they stand on their own. So given that assumption, you can actually put them in different classes. And so we've done some tests with that, and it actually makes a difference. So if you can't have a separate tier, you can still make significant improvements with your isolation of metadata. And there's another, let's see. Let's see. Yeah, so I'm calling this variable metaslab groups only because the word hybrid has been used so many times that I had to come up with something. We could probably come up with a better name. But the idea here is that because the abstraction in classes for all your policies, as I mentioned before, is something actually you'd probably want to leverage and keep that abstraction maintained. It's just that instead of having a single VDEV in all of its metaslabs, you can sort of share them. And the idea here is that when the VDEV gets instantiated open, some of its metaslabs have been set aside or dedicated for use as metadata class. And so those get put into that class. Everybody else who hasn't had either been tagged as such or is currently not even activated can be part of the normal class. And that gives you the ability later to grow your metadata class if you need to, if you have some of the uninstantiated files there. There is an assumption here, and this is sort of an orthogonal project, but it does tie in because if you're going to put your metadata into the same pool that's, for example, doing RAID Z, the fact that we've called that out as a special metadata metaslab, why not mirror that? Why not just basically inline mirror that instead of doing the overhead of RAID Z? So that together with separating them out has a benefit. So it's not an all or nothing where you have to put dedicated metadata resources. You can actually benefit from carving up your pool in a more intelligent way, and then the policies of what you're putting where can sort of help you tune instead of right now, if you think about it, if we're streaming in 16 meg blocks, adjacent to those are these 4K indirect blocks. The indirect blocks, all this stuff compresses down. So you have a 16K indirect block or the D node, they're all 4K. So we're interleaving 4K transient data next to your 16 meg stream. And so that's just, we noticed that right away. So it's like, no, isolation was an obvious approach. And so that's what we've been working on. So the current state, we're validating both types of this isolation. The one is, it's more the classical one where you dedicate VDEVs, and then this new one where we actually have, in the same pool, a mixture of classes, so you can have different policies based on what you're doing. And so I think the time is right to sort of bite this off in OpenZFS. And so I'm looking for, input. At the bottom there's a URL, and we'd love your input. I'm talking fast and kind of blazing through this because I'm aware of the schedule. So I know I didn't do it justice, but I'll take questions. And then tomorrow, I also have this demoed. So if you're interested at all, we can sit down and sort of see how it plays out. Is that okay? Okay. That says I can take 3 questions because I can't see. Want to hear? Yeah, we anticipated that question, and we actually were writing it this weekend. I don't have them in a slide, and I didn't have a chance. You do your first metric, and you're like, oh, that's probably all RAM-based benchmark, and so the variance is pretty small. The one I did do that was interesting was a scrub. The scrub, I don't know the memory. I was going to say it's like 25 minutes versus 18 minutes. And it's not as fast as you would think because you still have to read the file data in the scrub because it's not actually doing a resolver. It's actually validating that as well. But that's as far as we've gotten. This is sort of brand new stuff. So, but as far as the fragmentation aspect, that's not a performance measurement per se, but we did actually verify that this sort of Swiss cheese throughout your array goes away. Basically, you have your metadata guys are sort of reusing themselves, and then it gives you more opportunity to stream out of your file data. So, another one up there in the middle. Okay, yeah, so there's 2 questions there. I'll take the last one first. It's like, what do you do when it's full? I sort of mentioned that in this environment, you sort of assume that they provisioned it correctly, but if you don't, it just falls back to the main pool. And then a follow-on of that is like, I had this thought yesterday, it's like, can we have a hybrid of a hybrid where you actually have you run your pool in that hybrid mode I just mentioned, but you have a fast tier in front of that. And I suppose that could work, but. And your first question, I've already forgotten. Yeah, well, actually, this is a good trivia question. I'll present it to the audience and see if there's any takers. How many different ways, different in terms of how they see and backed by different code, is there to display a VDEV, sort of the pool config in ZFS? Anyone want to take a guess? No, it's not 1,000. That's kind of off by 4. The other takers? I counted 8. 8 discrete. And so this is the point where we can optimize OpenZFS and have like one function that sort of shows all the different ones. Because as an implementer, that's like, it's a nightmare. It's like, I actually have my regression test has all different 8, because there's ZDB and there's IOStat, and anyways, there's 8 different ways to sort of see it. And it depends on the context. So if you do an IOStat, ZPool IOStat, you can actually see how much that tier is using and how close it is to its capacity. Does that answer it? Okay. One more? Alex. Yeah, oh yeah, see. Yeah, so there's actually classes of the metadata. The most obvious one is the DDT. So we call that out as like a special. Oh, you mean above ZFS? Yeah, you could do it. I mean, basically, if you think of the ZIO pipeline, there's a property thing on there. So you could pass down like a hint. So at that stage, when we say, hey, what's your preferred block or preferred class, you could use that information to do it. In Lustre, we actually use, I think it's unknown, or there's a metadata type, and we do that because we want the doodle block. So, thank you.
Cool. So thanks, Don. Oh, do you have the microphone?
Oh, yes, I do. I thought that was my prize.
So thanks, Don, for actually getting us basically back on schedule. Few closing announcements. The location tomorrow is different than where you are right now. It's going to be at the GitHub headquarters. It's about a 20-minute walk. This is the address. It's also on the website. The schedule is basically the same as today. Breakfast at 9. Hackathon starts at 9:30. We'll start with going over what projects have been proposed and try to get people kind of paired up to work together, paired or larger groups. The dinner is going to be at GitHub, catered thanks to our sponsors. Remember to bring your badge again tomorrow. That'll help you get in faster. Here's a map. It's like a 20-minute walk from the Montgomery BART stop. Okay, so now, in closing, we can either stick to the schedule and go eat dinner now, or we can have fun Q&A story time with Matt and Jeff. Okay, Jeff, come on up here. Also, do we have special dessert? Yeah, can you bring in the special dessert? We're not going to eat the special dessert. We're just going to show it to you.